Okay, this will be another video, and this video is showing the project that I got going on, but what I'm going to do is show you how the jack shaft system is supposed to work if you're doing an aftermarket motor on a Honda Odyssey. And what I'm going to use as an example is a go-kart over here, because it's the same principle and the same setup. But over here on my project, let me go show it to you. I have the motor kind of placed in here just to show you. I don't have motor mounts or stuff made yet. It's still a project in working order. I got the carburetors off, exhaust off, and stuff like that. But the thing I'm going to show you is that you see there's the primary clutch that's on the motor. The belt drive will go to the secondary clutch. And then right here you can see the sprocket down there on the jack shaft. There'll be another sprocket right up here. Now for the example. Here is a Murray go-kart. I took the covers off to show you how this jack shaft system is exactly the same. Primary clutch, secondary clutch connected with the belt. You can see the jack shaft right there. Goes over here to a sprocket which goes down to the axle which runs that. It's the same principle. If you need to, find you a Murray go-kart and just kind of copy the same thing to what you're going to do on your Odyssey. Now my Odyssey does not have the same axle system as most people with their Odysseys. Most Odysseys already have the secondary clutch set up on it, and they have a gear reduction already in the box. Now being as though this is a highly modified unit, we've got to go with a different system. And so that's why I'm giving you information like this. I've seen on the web, but there's a lot of questions. How do you do jack shafts? Well, this is how you do it. This shaft right here will be mounted on bearings. I'm going to be probably having a whole new axle or a shaft made on that thing. And I'm going to move the sprocket to somewhere here in the middle. And then line all that up. I'm still not sure about my sprocket ratios just yet. I'm going to talk to an engineer using the tire height and probably whatever the ratio is coming off let me get my shadow out of the way, of the drives, and try to figure it out. I want good takeoff, top end 50-60 be about it. But I need really good low end, because that's where you're going to spend the majority of your time. But I don't want it to be, screaming at 35 miles an hour. I want it to be able to run good. This go-kart over here I picked up off a kid and redone it. And it's got great pull for just a 6 horsepower Tecumseh motor. And it's durable. And that's what I really like about this thing. And the system is quite simple. You see they were smart and they used a very large chain size. Now that gear ratio, I haven't counted it, but I'm going to bet that's around 7-to-1 ratio. But I'm not real sure. Can't really tell right off the bat. And the good thing about these kind of clutches like this is that the ratios that they vary are incredible. While this one is going faster, the clutch itself expands. And while this one gets faster, it contracts. And that's how you go from ratio to ratio. And that's how you get your speed and pulling power out of these. That's what I'll be doing to my Odyssey right here. Like I said, it's a work in progress. And I got a long way to go. And it was fun picking that motor up and putting it in there. I still got to make motor mounts and all this other stuff. Get a pipe for it, fit the pipe, fit the carbs. I mean, tons of stuff. Fuel system and stuff like that. But my concern on this one is getting the ratio right. I got to redo the rear axle so it can withstand that horsepower and handle it. But right now, as you can see, that sprocket that's on there, that is not a very big sprocket. So I'm guessing that I'm going to have to go up on ratio size to be able to get this thing to pull right and stuff like that. But I wanted to show this because I've been looking on the web for information on jack shafts for Odysseys, and there's not a lot out there, and that's why I'm doing this video, is to give you guys an idea of what I learned, or to let you know what I've learned, and to show you where I'm going with on jack shaft system. But copy the go-kart system. It works. It works great. This thing can pull a little kid to a big fat fart like me, so it works good. And that's what I expect this one to do, is to be able to pull something, you know, pull good, get up them hills, do everything that I want, and more, and be durable. And so that is going to give you an idea. You know, I just laid everything in there. It's not really precise right now, but it's to give you ideas of how to do this. I'll probably be letting the machine shop do a lot of the precision stuff, since I'm just working out of a crappy little shop right now. But it's to give you an idea where to go and how to do this sort of stuff. So these snowmobile motors are great for Odysseys. There's a ton of horsepower in them, and they're very lightweight, and they have the clutch system. That's why a lot of guys look at them. You can see tons of videos on YouTube about using snowmobile motors, but I ain't seen no videos out there how they set them up. So that's why I wanted to put this one out there. The Odyssey is run by a secondary clutch system just like this, except that it goes to a gearbox which then runs the axle, and it's a solid axle design. That is different than this, but like I said, I'm going to copy the Murray go-kart and put it on this one. And if you guys out there that are wanting to do a system like similar like this will give you a good idea on how to do it. You guys that are good with welding and machining and stuff like that, this will be not a problem for you. You'll be able to do this up, get your Odyssey some massive horsepower. I got lucky and I found this in a junk pile, and it's got a rear suspension on it. I will be probably redoing this suspension to make it more durable and to work better. But to get you to show you the motor system, how it's going to line up, how it's going to work, that's what you need to know right there. And like I said, I haven't figured out the gear ratio as far as what I need. It's going to be dealing with tire diameter and the ratios off that. And I'm going to guess it's going to be above 5, maybe even 7. That little Murray right there will hit about 30 or 40 and pull an adult-sized rider on it. Runs good. So I may have to look at them ratios right there too. But anyhow, I'm going to try to talk to an engineer and figure all this stuff out. But here's some information to get you guys going and figure this stuff out, to give you an idea of what you need to do. Now I get the fun part of putting this all, taking this back down and putting it in the box, and then putting that thing back together. So, alrighty, here we go. And you guys build some good stuff and put the information on the web. Let everybody in the world know about it. That way we're all getting smarter, not stupider. Alrighty, y'all have a good one.